Thank you, Hans, and good day to everyone. Thank you for joining us. I'm going to provide some introductory remarks to Frank's main event and just give you kind of a high-level overview of some of the messages we'd like to communicate today. So moving to the first graphic slide, I want to first talk about the importance of smart charging for e-mobility from a wholesale or bulk power system perspective. The top slide, top graphic is from modeling done a few years back by University College of London, Imperial College of London, that shows the UK system and assumes 30 million cars, electric vehicles with 10 kilowatt batteries on the system. On the left is the impact of uncontrolled charging. And as you can see, the result would be, despite a relatively modest increase in overall energy demand, a significant 20 to 30% increase in peak demand, which would require a massive investment in generation and grid capacity. Smart charging could effectively eliminate that need, at least for much of the first phases of the expansion of electrification of transport, while also mitigating the other side of the energy transition coin, which is renewables integration. And if you look at the bottom slide, which Frank, you may have to click to get to, the use of smart charging, not just for electric vehicles, but for other large and intrinsically flexible loads, can significantly improve the utilization of existing system assets. These benefits accrue to all consumers, not just those consumers that are able and willing to participate in smart charging and smart consumption overall. If we move to the next slide, we look at the importance of smart charging from the retail or distribution level of the system, and similar benefits are potentially available from smart charging. What we see here is 3 representative distribution systems in Europe, and what they illustrate is the vast amount of grid capacity that's available for use by loads such as EVs that are intrinsically flexible. We know from experience in Norway, as an example, that without incentives to shift charging away from peak distribution system hours, the great majority of drivers will simply begin charging when they return home from work, coinciding with the existing rush hour on most distribution networks and significantly stressing distribution systems that already require a large amount of capacity that operates at very, very low rates of utilization. The slide, the graphic that shows up on the right, Frank, if you are showing that, shows that even on peak days, on system peak demand days, in this case in France, the day of the highest demand on the system, in this case, the picture is even more stark. In this case, the difference between the maximum demand on the system in the course of the day and the minimum demand was 13 gigawatts. And this was in 2014, I believe. And the French system has only grown peakier since then. So smart charging has the potential to enable significant growth in EV adoption without the need for any significant new investments in distribution networks. We move to the next slide, Frank. So then the question is, if it's so beneficial, can we do it? And if we can do it, will we do it? And these are 2 questions that often come up in these discussions, or in some cases, objections that people have traditionally made to the idea that we can actually make any significant amount of electricity load more responsive to system conditions. And the first graphic that appears here shows the results of dozens of pilot projects that have been conducted using a range of different combinations of pricing, tariff design, retail tariff design, and the deployment of enabling technology. these pilot projects have demonstrated quite strongly that we can do this. Many end uses of electricity have always been intrinsically flexible to some extent, but it's only recently that information and communication technology has made it cheap, convenient, and easy to exercise that flexibility. And as the cost of flexing demand has come down, the value of doing so is rising rapidly with the growing penetration of variable resources on the system. The next graphic that appears is an attempt to answer the question, will we do it? We certainly know we can do it. Will we do it? This is just one example of a real-life demonstration that we will, as long as we make it convenient, easy, and cheap. This is the Octopus Agile Tariff, or the Agile Tariff option that is available from a commercial retailer in the UK named Octopus, Octopus Energy. And this is actual real-life results of customers who opted for the Agile Tariff, which provides half-hourly prices day ahead for use either directly by consumers or in prices to devices through aggregation and automation or remote or direct control. It's quite clear that consumers will respond. Consumers who are on the Agile Tariff are saving 30 to 50% on their electricity bills compared to what they would pay in a standard flat rate tariff. And importantly, that's only employing the energy or wholesale component. To achieve the crucial retail distribution system benefits I described a moment ago, regulators need to extend dynamic pricing to network charges, as Denmark has done recently for customers of Copenhagen's Radius network. So the conclusion that I'd like to leave you with as we move on to Frank's more detailed presentation is that the deployment of intrinsically flexible demand is crucial, not only to the electrification of transport and other sectors, but also to facilitate at the same time the integration of increasingly variable resources onto the system in a manner that is cost-effective and reliable. Not only is it critical, but it is eminently feasible. We can do it, and we've demonstrated that we will do it, as long as we use a combination of smart tariffs for both energy and network components of the pricing, the deployment of enabling technology, and other factors that have been identified in various reports that we and others have issued, including consumer education and effective regulation of competitive practices. So as we move on to Frank's presentation, those are some thoughts I'd like you to keep in mind. And Hans, why don't we switch over, or Frank, why don't you take over the slides?
Okay, thank you very much, Mike. Yeah, I think thank you for this invitation to present in this webinar. My name is Frank Geerts. I'm working for ELAT. As some of you might know, ELAT is a foundation funded by the Dutch DSO's around 10 years ago. And we are a non-profit knowledge and innovation center in the field of smart charging. And I'm the director of smart charging in that within ELAT. And I have to excuse myself for being a believer in smart charging. So if you think Frank is too enthusiastic, please bear with me. This is what I become to believe in the past 10 years. And the book that I'm presenting today is actually a gift that we gave away last year with our 10 years anniversary of ELAT. And I'd like to go through this book, the highlights of this book in this presentation. So we did write this book as a gift to the public, but we also see that a lot of new people are entering the smart charging industry or the charging industry. And we thought it would be a good idea to share the general knowledge about smart charging but also provide a book for some self-study, and correct also some misunderstandings about smart charging. Because when you talk about smart charging, a lot of things come to mind to people, and people sometimes get disoriented. But in fact, it's quite simple. That's what I want to share with you. Smart charging is not difficult. And I'd like to quote a Dutch famous soccer player. He is called Johan Cruyff, probably known. And he said, well, once you see it, or you see it once you understand it. And once you understand it, you see it, and it's simple. And that's what I hope to achieve with this book and this presentation, that you get a better understanding of how smart charging works, and that in fact it's quite simple. To add to Mike, I think that the introduction words are quite on topic. Please bear in mind that we live in a unique time. The electricity has entered our homes a century ago, but in the time we are living, we are really changing the electricity system that as we know it. So we are in the middle of an energy transition, which I think is very exciting. But we also should bear in mind that this is not an incremental change of the electricity system. It's a fundamental shift, a fundamental change, which does not only include mobility, but also the swift shift to renewables, electricity heating and cooling of the earth warming. So there are multiple things changing at the same time, and mobility is just one of them. So let's do a small thought experiment. I once learned that when you have a fundamental change, you should begin with the end in mind. So when we look at mobility, I get 4 questions which I usually ask to the audience to give some numbers. That's not possible via webinar this time, unfortunately. But the challenge of 100% EV would be, do we have enough energy? And do we have enough renewable energy? Because we want to become CO2 neutral. But apart from the energy, can we also generate and transport the power that is needed to charge the cars, especially when we want to charge the cars simultaneously? And to answer those 4 questions, I'm going to the next slide with a lot of information in it. Please read it back afterwards. But when you look at an electric car, it's a quite unique thing, at least from an energy perspective. From a mobility perspective, I would say it's just a better car compared to a combustion engine car. And the way we use the car, an electric car, will not be that different than the car that we have now. And please remember that we don't drive the car as far as you might think. And that's what is stated in the circle. And the numbers that I present there are basically the same, at least through Europe, but I would argue in the rest of the world as well. Because when you travel your car, when you're going to work, about an hour travel time is the max that you want. And that explains why the distance you should travel is not that much as one would expect. But a car is very special from an energy perspective because it has a huge battery. Over 100 kilowatt hours will be the norm in the near future. But it also has a very high power output or power input. If you compare it to a normal household in the Netherlands, the power that a car would demand is similar to 10 households in the Netherlands. So adding an electric car in the street is the same as adding 10 houses. And that's also the challenge that we are facing, and that was Mike was referring to. It's not the energy amount that a car needs, because we don't travel that much. The energy amount in the Netherlands is comparable. One car requires as much as energy as one household, but the power it requires is times 10. And that's when you compare the energy demand and the power demand of electric vehicles to the Netherlands national production, you see that the power required is 3 times as big just by passenger cars as the total production, electricity production capacity in the Netherlands. So if only the passenger cars would all be electric, we could simply not charge them simultaneously because we would have to install 3 times as much electricity plants. And this brings me to the next slide, that, well, is it feasible to expand electricity production capacity 3 times just for passenger cars? And I don't think so. I think in the future electricity system, it will be important to what I have called ride the waves of renewable power. As we do have controllable production plants now, when we shift to renewables, the production becomes dependent fully on the weather. And we have to harvest the electricity when it's there. And we have to spare it for times when the conditions are not that favorable. And I set here a question below that sometimes people think that the negative prices for energy are very attractive. But if you are an investor in power plants based on sun and wind, you need a return on investment and you need a minimum price to get your investment back. So I think this is a temporary situation of negative prices. There will be a bottom price, and we need to be more flexible in charging your car when the electricity production is available. And that also relates to the power grid, because the power grid is not dimensioned for these kind of power requests either. But we don't need to expand it because the production will not expand 3 times. But also, please remember that the solution that we tried or we needed to take in the past century by reinforcing the grid whenever there was new demand, we can simply not cope up with it when we change the electricity system fundamentally. And I put some reasons here why that's the case. And from an efficiency point of view, as Mike pointed out, it is not necessary. The smart charging option is the far better option than installing power plants or expanding the grid. And then when we look at smart charging, how does that work? And to explain that, we developed what we called a 4-layer model, where we have 4 different perspectives on how smart charging needs to be organized. And I will go through these layers one by one. And the first layer is the layer of technology, or I should say hardware and software. And I said smart charging is simple. And from a technology point of view, it is indeed very simple. Smart charging is nothing more or less than a control signal between an electric vehicle and the charge station itself. And the EV, the vehicle and the charge point negotiate about the time that the charge will take place, with which power outputs it will take place. And when you look at the future, you might also take the energy flow, the direction of the energy into account. Are you going to charge the car, or are you going to discharge the car, for example, to support your house on a day that there is less wind or not that much sun? This is some future features, but it's definitely something that needs to be part of the control signal. So this is what the control signal in basis is. And the thing about smart charging is that you need some intelligence to determine what the power, the time, and the direction will be. And this intelligence can be located at different parts in the system. It can be in the car, in the charge station, sometimes in parts of the power grid, but also to some dedicated systems like a home energy management system. And all those locations can be on site, but they can also be in the cloud. And this intelligence determines the output of the control signal. Well, to make the intelligence work, you need some raw materials. And that we call data. You want data to determine what is the best time to charge your car or to discharge your car over time. And I here listed some of the data points that you would like to have for your intelligence to determine the control signal. So this is the hardware. And now you can control a session. So what can you do for control if you look from an individual point of view? Well, you can basically do, as an end user, what you notice is that you, compared to a standard power charging, you might charge faster or a bit slower. You could choose to pause the charging, and you could choose to resupply, or V2G or bidirectional charging to change the direction of the power flow. And this is very important because when I move to the next slide, this is what a lot of people in this industry are talking about. They are not talking about an individual session, but they are grouping sessions and try to influence or to manage the energy systems on a higher level. And this is very good because this helps managing the balance, but we should never forget that behind these numbers, behind these groups, is an individual charge session and an individual user who has some demands and expectations about his charging car. Well, this is typically what you have seen before at demand-side management solutions. And this is what you can do with smart charging as well. To make this all happen, when you have the hardware and the software, you have different locations where the hardware and software is located. You need to have those different devices to communicate to each other. And this is the second layer of the model. We call that the machine-to-machine communication. So it's still technology. But here you have all kinds of protocols and standards between technical devices, negotiating about the control signal and sharing information to feed the intelligence. And in general, we determine, or we distinguish three kinds of machine-to-machine models. Either one where the charger plays the central role, or you could do it via the car. And the last one is via a home energy management system or a building energy system, where the data is located and that controls either the car or the charge station. In the last decade, a lot of work has been done in the field of protocols and standards. And I would say that these protocols are now mature enough to be used, like Mike said. The concern I do have with standards and protocols is the cybersecurity and the safety. We did some groundwork, but when we are going to roll out and to really make large numbers, I think we should improve cybersecurity on different aspects. And you might have noticed in the slides that I put some links to YouTube. And well, if you have some time this holidays, I can recommend you to watch the animations that are behind those YouTube links, because they give some more in-depth insight in, for example, the cybersecurity at this point. So when we have the hardware available, when we have the communication arranged, then it's time to go to the next layer. Sorry, I included an extra slide which I normally don't have in my presentation, but I decided to include it because I'm also chairman of a national work group in the Netherlands dedicated to smart charging. And in that working group, we have listed the requirements for electric vehicles and for charge points, which make smart cars and charge points smart charging ready. So to say, to be sure that the technology is able to do smart charging. This document will be released beginning of next year and is also available in English then. And this can help you in countries where you want to have a head start to make sure that your infrastructure is ready for smart charging. Then you can have a look at the document and see the standards that are currently in place and enable you smart charging in the near future. So the technology is ready, and then the interesting part comes, and that's layer 3. That's the organizational layer. And for the organization layer, I'd like to make a comparison to some music. When we see the technology, I would say, well, those are the notes of the music, but they do not yet make a song. And they definitely do not make a song that's in harmony. And this is where the organization layer is required. How do roles and parties relate to each other so that smart charging becomes really some music? And here we have competition, because some parties will say, well, I like classic music, and others want to have rock music or dance music, or they want to play jazz. That's all fine, but you can't do it all at the same time. But consumers might have a preference for one of the musics. And that's what the commercial products and services should do that need to be developed around smart charging. And in that competition, I think it will be the most interesting in the coming years to see who will become the conductor of the smart charging, who will get the end control of the control signal for smart charging. Will it be a car manufacturer that makes smart charging possible when you leave your car? Will it be an app that is provided by a CPO that allows you to install some smart charging? Or will it be a service that is provided by your home energy supplier that gives you a home energy management system that helps you in managing the energy and electricity in your house? And this is, I think, the next step that we need to take in this market, and it's very exciting because we are not talking anymore about technology, we are going to talk about business. And when you look at these businesses, what we did also in the Netherlands regarding the National Working Group is that we made an overview of the concerns that different roles currently have regarding smart charging. And this much relates to their own role. And you see here at the top, the most mentioned concern is related to the business case. And I think this is quite logical also when you listen to the introduction of Mike, that you see the energy system is changing. And so also the pricing of the energy system will change. And that makes people uncertain about the business case, because in the end, charging is about delivering energy. But you see also a lot of concerns with regards to the driver or the end user. I would say that's group 2, 3, and 4. And it's about making drivers understand how this smart charging works. People, I think, are not hesitant to switch to electric vehicles because the car is simply better, but they are hesitant or concerned, or they need more information about how to charge your car, because that's new. But also when you want to smart charge your car, you get the requirement for more information. So there is a lot to be gained over there. And finally, the concern about technology. It's not about technology development anymore, it's more about technology compliance. So that brings me to the last layer, layer 4. When we talk about organization, you also need to get that legalized, or to get a legal framework in place. And I think in basic, you have 3 different types of legal considerations. The first, you need some contracts. And that's basically the contract that you need as a driver. You need a contract to charge your car. You need an electricity contract related to the charge contract to get the energy. And you need a grid contract related to the charge contract to make sure that you have access to the energy system. And these 3 contracts, they can be folded in different kind of relations. And there you have B2B contracts. You have companies that are bundling those contracts into a proposition for the end consumer. And surrounding all those free market contracts are the legal conditions that are set out and the laws and regulations by, for example, the European Commission. And I listed 4 of, I think, very important laws or regulation points that are currently being made or have been made in Europe, and especially regulation on the internal market for electricity. I can recommend everybody to take a good look at it. And I also put the links to the documents on the right, because this is essential material, I would say, if you want to do smart charging. A lot of things have been regulated and have been decided upon in Europe last year. And that's good, because that makes it we can make the next step in getting smart charging more commercial. Now, I put together in one slide the 4 layers and the different elements that I mentioned. Well, please have a look at it afterwards. I think it's, once you look at it, it might look quite complex, but I hope that I build it up in this presentation and it does make some sense at this moment. And of course, you can always read it back in the book as well. That brings me to the last point, because what to do next? And I think when we look at what to do next, my personal opinion is that the technology is ready. The technology is ready for electric vehicles and the charging infrastructure. We have made a document with the standards in it. We should take a next step in data access protocols and cybersecurity, as I mentioned, but I think at the moment it's good enough to start with it. The next thing that we need to prepare is point 2, and that's the power system. And there I add just to what Mike said, we need to make more flexible both the prices for electricity supply, but also the tariffs for power grid access to make the electricity system as efficient as possible. But we should also include some security of supply safeguards, because when all cars would charge together, the dimensions of the electricity system cannot cope with that, and we must make sure that we don't have a blackout by simply having too much cars wanting to charge at the same time. And I think that in the next years, we should go to point 3, and that is, well, exceed driver expectations. I think most people, once they have driven an electric vehicle, they simply say, well, this is better technology, and I would like an electric car. The range anxiety is diminishing because we have larger batteries, but I think we still have some way to go to also improve the charging infrastructure and to improve the smart charging services. And I think it's up to the market now to take up that glove and to, well, impress the drivers, exceed the drivers' expectations, and that we can benefit from this, this revolution that we are part of. Thank you.